Okay, so the first question. This is May, June 2021. Question paper 2, variant 1. The first question says, define density. Density is mass per unit volume, or it is the ratio of the mass of an object to the volume of that object. Part B says, figure 1.1 shows a solid pyramid with a square base. The mass m of the pyramid is given by m is equals to 1 upon 3 rho hx squared, where rho is the density of the material, h is the height, and x is the length of each side of the base. Measurements are taken as shown in table 1.1. So the measurement for mass, x and h is given along with the percentage uncertainty. Calculate the absolute uncertainty in length. The absolute uncertainty in length. Now, we know that the length is 4 centimeter and the percentage uncertainty is plus minus 5 centimeter, which means that there's an uncertainty of 5%. So 4 centimeter multiplied by 5%, which is equals to 0.2 centimeters. So 0.2 is the answer. Part 2 says the density rho is calculated from the measurements in table 1.1. Determine the percentage uncertainty in the calculated value of rho. So what is the percentage uncertainty in the calculated value of rho? Given that this here is the equation. Let's have the equation here. Now, let's make rho the subject of the equation. So rho is equals to 3m over hx squared. When talking about percentage uncertainty, the percentage uncertainty in rho, percentage delta rho, I know that it's the percentage uncertainty in m plus the percentage uncertainty in height plus 2 times the percentage uncertainty in x. Where did we get this 2 from? This 2 is basically power 2 of this x. And all other if all percentage uncertainties are added, if there is a power, that power is multiplied to that percentage uncertainty. So this becomes, what is the percentage uncertainty in m? It's 2%, it's 5% for x and 4% for h. 2% plus 4% plus for h and 5% for x. This is equals to 16%. Part C says, the square base of the pyramid in B rests on a horizontal surface of a bench. Use data from table 1.1 to calculate the average pressure of the pyramid on the surface of the bench. The uncertainty in your answer is not required. They just want you to calculate the pressure. Now, pressure is force per unit area. The force in this case is exerted due to the weight of the object. So weight per unit area. What's the weight? Weight is mass 19.5 grams multiplied by the value of G, which is 9.81. 19.5 multiplied by 9.81. But if you look here, they want the answer in Pascal, which is an SI unit. So the quantities involved here should also be in their SI units. Grams, 19.5 grams is not an SI unit. So we'll have to convert this into kilograms. This becomes 10 to the power minus 3 upon area. What is the area? Now, the pyramid has a square base, as we can see here. And each side, x, has a value of 4 centimeters. So the formula for the area of a square is length into length, or length squared. So this should be 4 squared, but 4 here is in centimeters. Once again, we'll convert it into meters. 4 into 10 raised to the power minus 2 squared. What value do you get for pressure? once you plug in this, plug this in the calculator, you get 120 pascals. This is the pressure exerted, average pressure exerted on the surface of the bench. Where did the 4 come from? Where did this 4 come from? Area. Area is length into length, side by side, L squared. This X is equals to 4 centimeters. This is where the 4 came from. It's the length of one of the sides of the square base. That's question number 1. Question 2 says a person uses a trolley to move suitcases at an airport. The total mass of the trolley and the suitcase is 72 kilograms. The person pushes the trolley and the suitcases along a horizontal surface with a constant speed of 1.4 meters per second, and then releases the trolley. The released trolley moves in a straight line and comes to rest. So there's a horizontal surface, and the speed of the trolley is 1.4. And when released, the trolley moves in a straight line and then eventually comes to rest, which basically implies that there are resistive forces. Assuming that a constant total resistive, they've mentioned this here, assume that a constant total resistive force of 80 Newton opposes the motion of the trolley and the suitcase. Calculate power required to overcome the total resistive force on the trolley and the suitcases when they move with a constant speed of 1.4 meters per second. So they're asking you for the power. They've given you the resistive force and they've given you the speed with which it moves. What formula? You can't use power as work done over time directly, but you do know that work done is force into distance upon time, which is velocity. So the formula that we use here is power is equal to FV. You may know this formula directly or you'll have to derive it. So F is 18, V is 1.4, 18 into 1.4 is equals to 25 watts. Part 2 says calculate the time taken for the trolley to come to rest after it is released. What is the time that it takes for the trolley to come to rest? Now, the trolley that we have, along with the suitcases, has a mass of 72 kilograms. This is our trolley with a mass of 72 kilograms. The trolley experiences a resistive forces of 18 newtons. The initial velocity of the trolley is, what is the initial velocity of the trolley? The initial velocity of the trolley is 1.4 meters per second. So we've got the initial velocity. We've got the force, we've got the mass. We can find out the acceleration and use that to calculate the time taken for the trolley. So acceleration is force upon mass 72 over 18, which is equals to 18 over 72, my bad. F is equals to MA, A is equals to F over M, 18 over 72, which is equals to 0.25 meters per second squared. Once we have the acceleration, we know that V is equals to U plus 80. The final velocity is 0. The initial velocity is 1.4. The acceleration is minus 0.25 because it's in the opposite direction to our initial velocity. It's the deceleration. Time. T is equals to 1.4 upon 0.25, which is equals to 5.6 seconds. 5.6. Sir, why 18? That is the friction force. I was confused. Shouldn't we use the forward force minus friction? No, because we need to calculate the time taken for the trolley to come to rest. The trolley comes to rest after it is released. So once it's released, Sami, there is no backward force. There's only there is no forward force. Sorry, there's only a backward force, the resistive force. So we can only use this, and this is what makes it stop. This is what causes this deceleration. Clear? Part B. At another place in the airport, the trolley and the suitcases are on a slope as shown in figure 2.1. The person releases the trolley from rest at point X. The trolley moves down the slope in a straight line towards point Y. The distance along the slope between point X and Y is 9.5 meters. The component of weight of the trolley and the suitcases that acts along the slope is 54 newtons. Assume that a constant total resistive force of 80 newton opposes the motion of the trolley and the suitcases. Calculate the speed of the trolley at point Y. They want us to calculate the speed of the trolley. Once again, to calculate the speed of the trolley, because there is a net force involved that basically causes it to accelerate, we need to find out the acceleration first. Acceleration is resultant force upon mass, which is equals to 54 minus 18, 54 minus 18 upon the mass, that is 72, which is equals to 0.5 meters per second squared. Once we have the acceleration, we know that it will travel a distance of 9.5 meters. V squared is equals to U squared plus 2AS. V squared is equals to 0 squared, the initial velocity is 0, plus 2 times the acceleration, 0.5, times the distance moved, or the displacement, which is 9.5. V is equals to 3.1 meters per second. 3.1. Part 2 says, calculate the work done by F for the movement of the trolley from X to Y. They're asking you for the work done by force F. What is force F? It's 54 newtons. What is the distance moved by the trolley in the direction of force F? 9.5 meters. So for 1 mark, we'll say work done is force times displacement. Force is 54. Distance or displacement in that direction is 9.5. And that gives us the work done 510 joules. 510. Is this clear? Part 3 of the question says the trolley is released at point X is equals at point X at time t is equals to 0. On figure 2.2, sketch a graph to show the variation with t of the work done by F for the movement of the trolley from X to Y. Numerical values of the work done and t are not required. How does the work done increase? The work done increase. How does the work done change? Sorry, not increase. How does the work done change with time? To figure out what actually happens, you need an equation that links work done with time. We only have one equation that links work done with distance. But we do know that S is equals to half AT squared. Why? Because the initial velocity was 0, so S is equals to UT. UT is 0 plus half AT squared. So I can say work done is force times half AT squared. The force is constant, half is a constant, acceleration is constant, work done is proportional to T squared. This is the graph that you need to draw. Y is proportional to X squared. What does the graph look like? It's a curve with an increasing gradient. Do you get this graph part? Any confusions? This is the only method to solve it. Basically, whenever they ask you to draw a graph of one quantity with respect to the other quantity, you need an equation linking the two quantities. And apart from the two quantities, everything else should be a constant. That is the only way that you can draw a graph. If in this case the force was changing or the acceleration was changing, you would not get the same graph. Part C says the angle of the slope in B is constant. The frictional forces acting on the wheels of the moving trolley are also constant. Explain why in practice it is incorrect to assume that the total resistive force opposing the motion of the trolley in the suitcase is constant as the trolley moves from X to Y. If the frictional force is constant, if the angle is constant, why is it that the total opposing force will not be constant? The reason behind that is when you talk about opposing force, friction is not the only force that opposes motion. Friction between the wheels in this case is not the only force that opposes motion. There's also air resistance. Air resistance also opposes motion. And air resistance is not constant if the speed is not constant. If the speed increases, air resistance increases. If the speed decreases, air resistance decreases. And for this trolley, the speed changes. It starts from zero. It starts from zero and it ends up at 3.1 meters per second. So the speed increases, which means that the air resistance increases with speed. That's question number 2. Moving on to question 3. A pendulum consists of a solid sphere suspended by a string from a fixed point P as shown in figure 3.1. The sphere swings from side to side. At one instant, the sphere is at its lowest position X, where it has a kinetic energy of 0.86 joule and momentum of 0.72 Newton second. So at this point, at the lowest point, the kinetic energy is 0.86. The kinetic energy is 0.86 and the momentum is 0.72. A short time later, the sphere is at position Y, where it is momentarily stationary at a maximum vertical height h above position X. The string has a fixed length and negligible weight. Air resistance is also negligible. So no air resistance, no friction. On figure 3.1, draw a solid line to represent the displacement of the center of the sphere at position Y from position X. So for the sphere that moves from Y to X or X to Y, this curved path is not the displacement. Displacement is the straight line from their centers, the shortest distance between their centers. Label, draw a solid line to represent the displacement. That's it, a straight line. We don't need to label it. Part B says, show that the mass of the sphere is 0.3 kilograms. Show that the mass of the sphere is 0.3 kilograms. Now, they've given you the kinetic energy. They have also given you the momentum. You may either use EK is equals to half mv squared, P is equals to mv. Use this equation, use the two equations, form two simultaneous equations, and solve for m. Or what you can also do is combine the equations first. When you combine the equation, EK is equals to half m. You replace V with V is equals to P upon M, P upon M squared. So EK is equals to P squared over 2M. We've done this in class. Kinetic energy is 0.86. P is 0.72 squared upon 2m. And that will give us the mass. M is equals to 0.301395, 0.30 kilograms. Calculate height h. What is height h? Now, how do we calculate height h? We know that the kinetic energy at this point gets converted into gravitational potential energy at point y. Because there's no other form of energy at point y, and there are no losses, all of the kinetic energy gets converted into gravitational potential energy. Ek gets converted into EP. What is the kinetic energy? 0.86. What is potential energy? M, which is 0.30. G, which is 9.81. H, which is our unknown here. So the height is 0.86 upon 0.3 into 9.81, which is equals to 0.29 meters. That's the answer to 3B. The distance between point P and the center of the sphere is 0.93 meters. When the sphere is at position Y, the string is at an angle theta to the vertical. Show that theta is equals to 47. Show that theta is equals to 47. So 0.93 meters. This is from P to the center. This is 0.93 meters. This is what they've told us. Distance between point P and the center of the sphere is 0.93. They want, so if this is 0.93, since we've got the same string over here, we know this will also be 0.93 meters. Now, they want us to find this angle theta. There's trigonometry involved here. If somehow I could form a right angle triangle out of this, that would basically help me get an answer. How do I form a right angle triangle? This is how I can do it. This here is a right angle triangle with this hypotenuse being 0.93, this side being 0.93 minus h. So this part here, from this point all the way up till this point is 0.93 minus h, which is 0.29. Cos theta is equals to 0.93 minus 0.29 adjacent or base over the hypotenuse, which is 0.93. We'll plug this in our calculator, and that should give the value of theta as 47 degrees. $46.5 degrees. 46.5 degrees, which is equals to 47 degrees. That is the answer. For the sphere at position Y, calculate the moment of its weight about point P. Now, this is a good question. What is the moment of its weight about point P when the sphere is at position Y. So let's copy the diagram. Let's have this here. Now, do we have the weight of the sphere? Yes, we do. We have the mass, which is 0.3 kilograms. So 0.3 into 9.81 is the weight of the sphere that acts downwards vertically. This is the weight of the sphere. To calculate the moment, I'll have to use force multiplied by the perpendicular distance from the pivot. Now, there are two ways to solve this question. You may either find a distance perpendicular to this force, a distance perpendicular to this force, which is this distance. So you can either find this out, which you can. You've got the hypotenuse, you've got this length. You can find out this distance. Or what you can do is you can resolve this force. You can resolve this force and find out this component. This component is at 90 degrees. If this is theta, this angle will be theta. This angle will be theta. And this component here, away from the angle, the component away from the angle is the sine component. So this becomes W sine 47. And this length was 0.93. Yes. So all I need to do is, for moment, I'll say force multiplied by perpendicular distance from the pivot. So force is mg, 0.3 into 9.81, multiplied by the distance. Sorry, 0.3 into 9.81 into sine 47. This is the weight multiplied by sine 47 into the distance, which is 0.93. Using this, we'll get our answer for the moment. Moment is equals to 2.0 Newton meter. Is this clear? You get the two approaches. You could have either used this force and gotten this length, or what we did was resolve the force and used this length, as long as you have force and the perpendicular distance. This way, some of you may wonder, why is it that we ignored the other component of weight? Why did we ignore this component of weight, even though this exists? The reason we ignored it is because this component of weight passes through the pivot. So the moment, there is no moment produced by this. Part F says, state and explain whether the sphere is in equilibrium when it is stationary at position Y. Is the sphere in equilibrium at this instant? No, it's not. It is not in equilibrium. And why is it that it's not in equilibrium? Because for equilibrium, there are two conditions. The net or the resultant force should be 0. The net or the resultant moment should be 0. This sphere experiences a force at Y, which is the weight of the sphere. This sphere experiences a moment at Y, which is 2 Newton meter. So not in equilibrium because net moment or resultant moment, let's use the term resultant, which is better. And resultant force is non-zero or not 0. If you just write down no without explaining, it's a 1-mark question. you won't be awarded any mark at all. That's question number 3. Moving on to question number 4. For a progressive wave, state what is meant by wavelength. What is wavelength? Wavelength is the distance moved by the wave in one time period. That's wavelength, lambda. A light from a laser has a wavelength of 416 nanometers in a vacuum. Calculate the period of the wave. So they've given you the wavelength. They're asking you for the time period. V is equals to F lambda, or V is equals to lambda over T. Because it's light and it's in a vacuum, we know that the speed would be 3 into 10 to the power 8 meters per second, which is equals to lambda, which is 460 nano 10 to the power minus 9 upon T, which is the time period. T is equals to 1.5 into 10 raised to the power minus 15 seconds. That is the time period. The light from a laser is incident normally on a diffraction grating. Describe the diffraction of light waves at the grating. What is diffraction when light hits the grating? So our wave spreads when it passes through the slits of the grating. This is diffraction of light waves at the grating. It passes through, it spreads when it passes through. What is diffraction? It's the spreading of light when it passes through an opening or a slit, or it hits a corner. Part D says a diffraction or grating is used with different wavelengths of visible light, the angle theta of the 4th order. So the order is fixed. Different wavelengths. The angle is measured. The angle theta of the 4th order maximum from the 0 order is measured for each wavelength. The variation with wavelength lambda of sine theta is shown in figure 4.1. Now, they've given you a graph of sine theta against lambda. The gradient of the graph is g. Determine an expression in terms of g for the distance d between the centers of two adjacent slits in the diffraction grating. Now, for questions like this, the first thing that you need to do is get an equation and linearize so that you get sine theta as y, you get lambda as x. Because it's a diffraction grating, the formula is d sine theta is equals to n lambda. What do we have on the y-axis? We've got sine theta on the y-axis. So we'll have it on the left side of our equation alone. N is 4 because for different wavelengths, it's always the 4th order. So it's not a variable for our experiment. It's a constant divided by d times lambda. We have lambda on the x-axis. Now this equation is in the form of our general equation of a straight line. You've got sine theta on the y-axis, you've got lambda on the x-axis. The gradient of this graph, the gradient of the graph is 4 over t. But the question says, they don't want an equation for gradient in terms of d. They want an expression for distance d in terms of gradient. So d will be equal to 4 upon g. 4 upon g. Sir, here I use lambda into 10 to the power minus 9 because it was nanometer. No, you don't change the formula if the units have a different unit, if the units have a prefix. So speed is equals to distance upon time is always the formula, irrespective of what units you use. When you add the number, that is when you adjust the prefix. On figure 4.1, sketch a graph to show the results that would be obtained for a second order maxima. For the second order maxima. So when the value of n changes, which is 4 over here, we know that the gradient changes. So the gradient, which was initially 4 by d, now the new gradient will be 2 by d. If you compare 4 by d with 2 by d, you realize that this newer gradient is half the original value. This was 4 upon d, this is half of that 2 upon d, which means you'll draw a straight line as it is, but with half the gradient or with half the steepness. So because we wanted to have half the steepness, this here is at 700. This 700 is two big squares on the y-axis. Our new line would be over here. 5 small squares or one big square. This is one big square. And in fact, let me use this original line and tell you this would have been an identical line with the same gradient. But we don't want an identical line with the same gradient. We want it to have half the gradient. So the rise over run, change in y1, change in x would be different. So this is here. This is 6 small squares. 1, 2, 3, 4, 5, 6 small, approximately 6 small squares. So this would be 3 small squares. Is this clear? This is what a new line looks like. Question number 5. State Kirchhoff's second law. What is Kirchhoff's second law? Kirchhoff's second law is Kirchhoff's voltage law. So it says that for a closed loop, the sum of EMF is equal to the sum of the potential drops or potential differences across the loads. Potential drops. That's Kirchhoff's voltage law. Part B says a battery has EMF 4 volts and internal resistance 0.35 ohms. The battery is connected to a uniform resistance wire XY and a fixed resistor of resistance R as shown in figure 5.1. So we've got our battery here, has an internal resistance 0.35, has an EMF 4 volts. There's a resistor R and there's a uniform resistance wire XY. Wire XY has a resistance of 0.9 ohms. So this one has a resistance of 0.9 ohms. The potential difference across wire XY is 1.8 volts. So if you were to connect a voltmeter, this voltmeter would read 1.8 volts. That's the potential difference across the wire. Calculate the current in the wire. They've given you the resistance of the wire. They've given you the potential difference across the wire. They want you to calculate the current. V is equals to IR. V is 1.8, I is the unknown, R is 0.9. 1.8 upon 0.9, which is equals to 2 amps, 2.0 amperes. Part 2 says the number of free electrons that pass a point in the battery in a time of 45 seconds. What is the total number of free electrons that pass a point in the battery in a total time of 45 seconds? Now, this 2 amperes here, what is this 2 ampere? It's charge per unit time, which basically means that a total of 2 coulomb charge passes in 1 second. If I ask you, what is the total charge that passes in a time of 45 seconds? You know, Q is equal to IT. 45 multiplied by 2, or 2 multiplied by 45, basically 90 coulombs. But that's not the answer. They don't want you to tell the total charge. They're asking you for the total number of electrons. For that, you need to know the charge on an electron. An electron has a charge of 1.6 into 10 to the power minus 19 coulombs. If 90 coulomb passes, how many electrons make or contribute to that charge? Or how many electrons make up 90 coulombs? So simply 90 over 1.6 into 10 to the power minus 19, which is equals to 5.6 into 10 raised to the power 20. Okay. Moving on. Part 3 says resistance R. So we've got the value of current in the wire, which is 2 amperes. So if this is the current in the wire, this is the current that leaves the battery. This is the current that passes through resistor R, 2 amperes. They want us to calculate the resistance of R. I know that for this closed loop, I can use Kirchhoff's second law or Kirchhoff's voltage law. The total EMF is equal to the total potential drops, IR. The total EMF of the circuit is 4, is it? Yes, 4 volts. 4 volts. The total potential drop is 1.8 volts for the wire, 1.8 volts for the wire, 2 amperes multiplied by R, V is equals to IR, V is equals to IR, 2 multiplied by R, 2R for the resistor, plus 0.35 into 2, which is equals to 0.7 for this resistor, plus 0.7 volts. So I've got the EMF, all the EMFs, which is, there's only one EMF. I've got all the potential drops. I can use this to calculate the value of R. R is equals to 4 minus 1.8 minus 0.7 divided by 2, which is equals to exactly 0.75 ohms. That's the answer to part 3. C part 1 says, a cell of EMF 1.2 volts is connected to the circuit in B as shown in figure 5.2. The connection P is moved along the wire XY. The galvanometer reading is 0 when the distance XP is 0.3 meters. Calculate the total length L of wire XY. So this distance here, XP, is 0.3 meters. The total length of this wire XY is L. The total potential difference. Now, I know that because it's a uniform wire, the potential drop across its length would be uniform. There'll be a uniform potential drop per unit length. So if the total wire, in fact, the total wire experiences a potential drop of 1.8 volts. So half the wire would experience a potential drop of 0.9. Quarter of the wire would experience a potential drop of 0.45. We can use that ratio. I know that the total length L experiences a potential drop of 1.8 volts. And because it's balanced at point P is 0.3 meters and the battery is 1.2 volts, the EMF of the battery is 1.2. I know that 0.3 meters experiences a potential difference or potential drop of 1.2 volts. This will only be balanced if the potential drop across this wire is equal to the EMF of the battery. We'll cross multiply, solve for L. L is equal to 0.3 into 1.8 over 1.2. Which is equals to 0.45 meters. Any questions up till this point? Can I move on now? The fixed resistor is replaced by a different fixed resistor of a resistance greater than R. State and explain the change, if any, that must be made to the position of P on the wire XY so that the galvanometer reading is 0. State and explain. Now let's go back to this diagram. So this total wire XY experienced a potential difference of 1.8 volts. In part B, why didn't we use? We'll come back to part B. Remind me at the end. We'll go back. So the total wire XY experiences a potential difference of 1.8 volts. Now, if I increase the resistance of this wire, the total resistance of the circuit increases. And the total current of the circuit decreases because IT is equal to EMF over the total resistance. If the resistance increases, the current decreases. If the current decreases, because this wire has a fixed resistance, the potential drop across this wire would decrease. So that's the first point. Potential difference across the wire decreases. Now, what does this mean? So this basically means this goes from 1.8 volts. Let's say it goes from 1.8 volts to 1.2 volts. Let's take that value, which means that the total potential drop across XY is 1.2. So for this to be balanced, we need 1.2 volts, which means we'll have to connect it to this end at Y. So when the potential decreased, we had to move it to the right. So even if it does not, drop to 1.2, if it drops to 1.6 volts, we'll still have to move it to the right. You can use the ratio again, use this as some smaller value, 1.6 volts, take the total length as it is 0.45, and then find out what length you need. You need a length greater than 0.3 meters. So position of P is changed and it's moved closer to y or further away from x, closer to y or further away from x. Last question, question number 6. A proton in nucleus decays to form a neutron and beta plus particle. State the name of another lepton that is produced in the decay. Whenever you have a beta plus particle decay, beta plus decay, or a positron decay, you get the other lepton. Beta plus is one lepton. The other lepton that you get is an electron neutrino or a neutrino. State the name of the interaction force that gives rise to the decay. Weak nuclear force is responsible for this decay. State which of the three particles, proton, neutron, or beta plus particle, has the largest ratio of charge to mass. State which one has the largest ratio of charge to mass. Now, neutron has no charge, so it's out of question that this may be the answer. It's either proton or a beta plus. They both have the same charge. For the largest ratio of charge to mass, the mass should be smaller. And we know that beta plus has the same mass as a beta minus, which is the same as an electron, 9.11 into 10 to the power minus 31. So beta plus, obviously, because it has a smaller mass, for the same charge as the proton, beta plus has the largest ratio of charge to mass. Use the quark model to show that the charge on the proton is plus E, where E is the elementary charge. So for a proton, the quark composition is up, up, down, where each up is plus 2 upon 3e, and a down quark is minus 1 upon 3e. Plus 2 upon 3 plus 2 upon 3 is equals to 4 upon 3, minus 1 upon 3 is equals to 3 upon 3e, which is equals to 1e. Part 5 says the quark composition of the proton is changed during the decay. Describe the change to the quark composition. What is the change? You can either say that up, up, down, which is the charge, which is the quark composition of a proton, because they've told you that a proton decays into a neutron, gets converted into up, down, down, which is the quark composition of a neutron. Or you may say that one of the ups gets converted into a down quark. An up quark changes to a down quark. Part B of this question is from the topic electric fields, which is not part of the question, not part of the syllabus anymore. So we'll skip that. So that's it.